Hello everyone. Today's class we will discuss few numericals of Nernst equation. Okay. Now see this one here it is. This one is the Nernst equation where E cell equal to E naught cell minus 0.059 by n log of anodic ion concentration of anodic ion to the power x by concentration of cathodic ion to the power y. You see? To solve any numerical which is based on Nernst equation, we have to know all these terms. First one is the EMF of the cell. This one is the EMF of the cell at standard condition. Okay, minus 0.059. This one is the constant. N is the number of electron transferring. Okay, next anodic ion and cathodic ion, and this one X and Y is the number. Sorry, X and Y are the moles of anodic ion and cathodic ion respectively. Okay, now see, to know about the anodic ion, cathodic ion, we have the clear concept about the cell representation or cell reaction, that is which is going to oxidize or which is going to reduce. Okay, now see, let us see an example. See, Nernst equation for Daniell cell. As you know, Daniell cell consists of copper and zinc electrode, and the salt solution is of zinc salt and copper salt. Suppose this one is the zinc solid and copper 2 positive aqueous goes to copper solvent, zinc 2 positive aqueous. Suppose zinc 2 positive, this one oxidation, and copper 2 positive copper 0 is reduction. Okay, this one reduction. See, what is the cell representation? Cell representation is the zinc solid, zinc aqueous, double dash, copper aqueous, copper solid. That means this one is the left hand electrode, this one is the right hand electrode. Okay, here left hand electron, this one is the what? Which ion? This one is the anodic metal, anodic ion, cathodic metal. Okay, so Nernst equation becomes E cell equal to E naught cell minus 0.059 by 2 log of zinc 2 positive, that means anodic ion, copper 2 positive means cathodic ion. Since 1 mole of zinc 2 positive and 1 mole of copper 2 positive aqueous is used in this reactions, that's why here is X and Y both are 1. Isn't it? Okay. This is a very simple thing. Okay, now let us take a numerical. Suppose reaction is given. Represent the cell in which following reaction takes place. Magnesium solid reacts with 2 moles of argon positive. That means argon, silver, not argon, this one silver ion, which have the concentration of 0.0001 mole. I can say molar, goes to magnesium 2 positive ion having the concentration of 0.13 molar plus 2 moles of silver solid. Remember, main thing is we are dealing on the cathodic ion and anodic ion, not the solid. Only the ion. This one is important and this one is important. This one is what? Anodic or cathodic? This one is what? This one is cathodic. Cathodic ion. This one is anodic ion. Okay. How can you identify which one is cathodic or anodic ion? If you write the cell representations, then you can clearly see which one is cathodic or anodic ion. Anodic ion will be in the left side and cathodic ion will be in the right side. But if you don't write or if you don't give any cell representations, then the ion which is with the this one anode metal is the cathodic ion, and the ion which is with the cathodic metal is the anodic ion. Just opposite case. Okay, and vice versa. Now you have to calculate E cell. If E naught cell is given 3.17 volt, that means standard EMF of the cell is given 3.17 volt. So this one is cell representation I have written here. Okay, cell representations. Now, what do you know? We know E cell equal to E naught cell minus 0.059 by n log of concentration of anodic ion to the power x divided by concentration of cathodic ion to the power y. This is the formula we know. Now, put the values. Now, E cell is given at 3.17 volt. 3.17 volt. N is 2 because if you see here 2 electron is transferring, but here is 1 electron. But if you remember the previous classes where the cell representations we have discussed, the electron in the both half cell reaction is cancelled. That means the electron in the reduction half cell and the electron in the oxidation half cell should be cancelled. To cancel each other, we should same the electron in the reduction reaction and electron reaction. That's why we are taking the LCM of 2 and 1. Nothing is there, no? That means 1. 2 and 1 has the LCM of 1. That's why I've taken here 1. Okay, now see next one. N is 2. Now concentration of anodic ion. See, anodic ion here is magnesium 2 positive, magnesium 2 positive. Now, how many moles of magnesium 2 positive is used in this reaction? That means 1 mole. Nothing is there. That means 1 mole. That's why here is 1. Cathodic ion means silver ion. Now see here 2 moles of silver ion is used. That's why here is 2. Now just put the values. This one is 0.13 as it is given, 0.13 molar. This one is 0.0001 mole. I'm written here 0.001. Okay. Now just do the mathematical part and you will get the values. Okay. Now what will be the value? Values is this one. The E cell, you will get the value of E cell equal to 2.961 volt. Okay. The mathematical part just do yourself. Okay. And no need to any query because I will give the systematic PDF notes also. Okay. Now see. Till now we are discussing about the particular reaction. Suppose Daniel cell, galvanic cell, voltaic cell. Suppose there is a reactions did not signifies any particular cell. Suppose there is a reaction, redox reaction obviously. A, small a moles of capital A. Here is A, small b, small c or small d's are the moles of A, B, C, D respectively. Okay. Now A, B, C, D are the reactant and C, D is the product. Now see. Small a moles of A, capital A, when react with small b moles of capital B reactant react, it forms small c moles of capital C product plus small d moles of capital D product. Now in these reactions the Nernst equation becomes E cell equal to E naught cell minus RT NF ln Q. This Q means the concentration of the product divided by concentration of the reactant. This one is very important. Maybe 2015 short question comes in your final examinations, that in board examinations, one short questions came from this topic. Okay. Now what will be the Nernst equation in case of equilibrium constant? Okay. Now see, at the equilibrium the E cell is 0. That means the EMF of the cell is 0 because in equilibrium the oxidation and the reduction, or you can say the reaction from left to right and the reaction from right to left is in equilibrium. That means in same. That's why E cell is 0. If E cell is 0, then what it becomes? Then E cell minus E naught cell minus 2.303 RT by N. This one is normal formula of Nernst equation, log of anodic ion to the power x and cathodic ion to the power y equal to 0. This one see, I have written here 0. Now at equilibrium, now we have to, since the reaction is in equilibrium, then we have to apply the equilibrium constant. Now equilibrium constant designated as Kc. Okay, Kc equal to the concentration of anodic ion to the power x divided by the concentrations of cathodic ion to the power y. Okay, next. If the E cell equal to 0, then if we just rearrange the above this one, if we rearrange the above equations and substitute the values of this part with Kc, we will get E naught cell equal to 0.059 by n log of Kc. Okay, 0.059, this is comes from the calculation of 2.303 into R. R means gas constant, 8.314. T is the temperature of, that means 25 degrees centigrade, 298 Kelvin, and F is the Faraday's constant, and you will get 0.059. Okay, and is the number of electron transferring. This is the relation between the equilibrium constant and Nernst equation. Remember this one. Here only the standard EMF is considering, not the normal EMF. Only the standard EMF we can calculate from this formula, because the E cell, that means EMF of the cell, is 0 since it is in equilibrium. Okay, see. Now there is a homework for you. What will be the equation for the relation between the Kc, that means equilibrium constant, and is inner cell for Daniell cell? Okay, this one. Now here is the electromotive force, electrochemical cell, and gives energy of radiation, as I discussed in the previous video. Okay, what is the relation between the Gibbs free energy and the electromotive force of the cell? Okay, that's why I don't repeat the question, and we will go the next topic. Okay, our next important topic is the conductance and resistance of electrolytic solutions. Now, what is electrolytic solutions? Before you know about the conductance and resistance, you have to know electrolytic solutions. Okay, first of all, now we will discuss about the electrolytic solution. Okay, see, to know about the electrolyte solution, we have to know what is electrolyte first. Suppose I am written here electrolytic solution. Okay, to know about the electrolytic solution, we have to know first term is the electrolyte. What is electrolyte? See, electrolyte are the substance which can dissociate into ions, that means positive and negative ions completely. Remember this one, completely, which can dissociate into complete ions, is called the electrolyte. Now, what is the meaning of dissociate? Dissociation means the breakdown of ions. Okay, suppose let us take an example here. Suppose NaCl, sodium chloride, is a well-known electrolyte. Okay, or you can say copper sulfate is a well-known electrolyte. When it reacts with water, it produces Na plus Cl negative. See, this one is the positive ion. Okay, wait 1 second. This one is the positive ion, and this one is the negative ion. Similarly, if we add influence of water, copper 2 positive, SO4 2 negative. This one is the positive ion, this one is the negative ion. That's why these are electrolyte. Okay. Now see, the passing of electricity through any water. Suppose, let us take an example. Wait, let me explain first what is the types of electrolyte. Electrolytes are of two types. Okay, electrolytes are of two types. First one is the strong electrolyte. Strong electrolyte means completely dissociated. Okay, completely dissociated. Okay, in the section, just don't use the completely word. Completely dissociated, such as this one. Let us NaCl, copper sulfate, suppose ACl, sodium acetate, this one. Another is weak electrolyte. Okay, weak electrolyte does not dissociate dissociate completely, such as CH3COH, that means acetic acid, ammonium hydroxide, etc. Okay, these are strong electrolyte and these are weak electrolyte. Now, how the electrolyte or electrolytic solutions helps in the conductance or resistance, we have to discuss this way. Okay, now see, let us take an example here. This one, suppose here is a beaker. Okay, simple beaker, only water means only H2O, you can say distilled water is there. Now if we want to pass, suppose here is a circuit, one wire is connected to this way, another wire connected to this way, and from here battery is there, then here is a switch or you can say key, then here is a simple bulb. Okay, simple bulb is there. If we on the key, the electricity will pass or no? What do you think? There is no passing of electricity. Why? Because there is no ion, only the water molecule is there, and only water molecule is a polar molecule and cannot pass the electricity. Okay, now if we add some salt here, NaCl, Na plus Cl minus, when sodium chloride is added in the water, it will produce sodium plus and chlorine negative, that means ion. Ion means what? Here is one electron is less and here is one electron is more, that means the movement of electron is started, that means electron is moving this way, electron is moving. If electron is moving, then obviously the current will pass from one end to other end, then the light will bright. Okay, then we will see the light is on, that means the electricity is passed only by the sodium chloride ion, which is the electrolyte, and this solution is called the electrolytic solutions. And for this electrolytic solutions, we can observe the passing of electricity. Okay, now if we observe the passing of electricity, we can say that the salt solution, or you can say the electrolytic solution, is a conductor of electricity. Okay, this is the main concept of electrolytic solutions and conductance. Now see, before you start this chapter, conductance and resistance, we have to know conductance. Conductance simply the carry out the electron movement. As I explained here, conductance means conduct the electricity or conduct the anything. Now what is resistance? In simple word, resistance means disturbance. Resistance is disturbance. In the conduction of electricity, resistance disturbs the system to decrease the conductivity of the electrolytic solutions. Okay, now let us explain what is the chemical formula, or what is the expression of the conductance and resistance of electrolytic solutions. The electrical resistance R, which is R of an object, is directly proportional to its length. Okay, that means more the length, more the resistance, and inversely proportional to the area of cross sections. That means how the thick is the substance or how thick the object. That is R, that means resistance is proportional to L by A. L is directly proportional, A is inversely proportional. Okay, if you write in different way, you can write R is proportional is L and R is proportional to 1 by A. Now if you plus these two equations 1 and 2, you will get this one, R proportional to L by A. Since it is proportional and we have to apply a proportionality constant, here the proportionality constant is rho. Rho means the constant of proportionality called the resistivity or specific resistance. It has three names, okay? Constant of proportionality, resistivity, and specific resistance, and it has the unit of ohm meter. It is ohm meter is SI unit, okay? Ohm meter. The unit may be ohm centimeter also, which is not SI unit, but SI unit is ohm meter, okay? As you know from the physics, the conductance is the simply the reciprocal or the inverse of resistance. That's why I'm written here G. That means conductance of the object is equal to the 1 by R, which is reciprocal. Okay. Now, if we put the values of R, this value here, we will get this one. This one is 1 A rho by L. Wait, let me see. Wait. Sorry, students, I made a little bit silly mistake. Okay, now it is correct. See, as we know, the resistance is the reciprocal of conductance, or you can say conductance is the reciprocal of resistance. That's why G, that means conductance, is the reciprocal of resistance. That means 1 by R. Now, if we put the values of R equal to rho L by A, here is rho L by A, we will get this one 1 by rho A by L. Here the 1 by rho is equal to kappa. Kappa is a Greek word, okay? Kappa means the specific conductance or conductivity. Kappa means specific conductance or conductivity, okay? This is very important. Now the SI unit of G, that means conductance, is Siemens. Siemens means the reciprocal of ohm, which is the unit of resistance, okay? Ohm inverse means Siemens. Now SI unit of kappa is Siemens meter inverse, which is also a SI unit, okay? I think it's clear. Now let's go to the next topic, okay? See, next is the electronic conductance of metal due to the movement of electron, which is depend on these properties. Next is the conductance of electricity ions by ions present in the. To explain this concept, we have to know a little bit deeper, okay? Now let us see here. Suppose here is a metal rod. It is a metal rod. Suppose iron rod, you can say iron rod. This one is an iron rod. Now see here, lots of atom or molecule or ion is there, okay? Mainly in the metallic substance, we are dealing with the valence electron, which can excited from lower energy level to the higher energy level, as I explained in the class 11 also, okay? Only the valence electron will participate in the excitation process, okay? Do not participate by the inner core electron, okay? Now the valence electron is the free to jump, other sense you can say, okay? Now since it is a metal, not the solution, remember this one, it's a metal solid. The valence electron will participate, or valence electron will influence its metallic or conducting property. Now what is the in what factors the conductance of this metal will vary? First dependence factor is the nature and structure of the metal, okay? Nature and structure of the metal means how the structure, what is the structure of the metal and what is the nature of the metal. That means if it is covalent type of compound, then it will be less conductor, and then if it is the metallic type of, suppose iron, copper, aluminum, this kind of substance, then it will be good conductor, this side, okay? Now next topic or next factor is the number of valence electron. If the number of valence electron is more, then conductance will be more. If the valence electron is low, then conductance will be low, okay? Third topic, or third factor is the temperature. Very important, this one. Temperature. When temperature T decreases, the conductance, that means G is increase. Suppose T is increasing, okay, T is increasing, then G will decrease. That means the temperature and the conductance of a metal is inversely proportional. Okay. Next thing is the conductance of electricity by ions present in the solution is equal to the electronic or electrolytic or ionic conductance. Now, to know about this concept, we have to know electrolyte or electrolytic solutions. As we discussed in the electrolyte topics, what is electrolyte, what is weak or strong electrolyte, how electrolyte is responsible to conduct electricity. Okay. Now, what is the factor? See, nature of the electrolyte is added. If we are added strong electrolyte, then the conductance will be high. If it is weak electrolyte, then conductance will be low. Okay. Next, size of the ion produced by the solution. If the size of the ions is bigger, then the movement of the bigger ion will be slow. That means conductance will be slow or low. If the ions are smaller, then the ions can move randomly. No, that means the conductance will be high. Next is the solvent and viscosity. Viscosity means how viscous the solid or liquid, solution, solvent. If it is less viscous, then the electricity will pass more. That means conductance will more. If it is more viscous, that means the conductance will be low, because in viscous liquid the ions cannot move freely. Okay. Next thing is the concentration of the electrolyte. See, concentration means how many ions or electrolyte present in the required amount of solvent. If it is more, then conductance will be more. If it is less, then conductance will be less. Because in the low concentrations, the number of ions will be low. That means conductance should be low. In the higher concentrations, the ions is high. That means the number of ions is high, which results the increase in conductivity. Okay. Next thing is the temperature. Temperature is very important. Okay. Temperature, it increases with increase in temperature. That means when temperature increases, conductance, that means G, also increases in the electrolytic solution. Remember this one, not in metal. Metal is inverse case. So how? Our questions arise how. Suppose let us take an example here. Suppose we have taken a solution in a beaker which have the conductance of 5, suppose 5 unit. If we just increase the temperature, then the movement of the ion obviously will increase, no, because of kinetic energy. Okay. Now the movement of the ion is increases. That means the conductance should be increased. That's why when temperature increases, the conductivity also increases, which is known as directly proportional relation. Okay. Next topic is this one, cell constant. Now, what is cell constant? Cell constant is simply the ratio of the length of the conductor divided by the cross-sectional area of the conductor, which is known as cell constant, and designated as G star. G star equal to L by A. Now, if we put the values from the resistance or resistivity and the conductance, you will get R by rho. Rho is the resistance, R is the resistance, rho is the specific resistance. Now R is here, 1 by rho is kappa. We know kappa is the specific conductance or conductivity. That means the unit of cell constants becomes meter inverse or centimeter inverse. Meter inverse is the SI unit. Okay. Thank you. Let me see in the next class. Okay. Have a nice day. Bye.